Jai Shri Ram. Today we are going to revise Laplace Transforms chapter from very basics, and along with that I'll also give you formula sheet. So this also you should write along with me in a separate sheet. So first let's see definition. So f of t is a function. So Laplace, if we have to apply Laplace, you have to remember that f of t is a function such that for every t should be greater than 0. So if t is positive, so only then you can apply Laplace on that function. So the Laplace is nothing but it's an integral from 0 to infinity. You will have one exponent term and the other term is function itself. So this we are going to denote with f bar of s. It's nothing, it's only we have f of t, no? So another function denotation we took f bar. And why we took s here is, see, for every function containing t, when you apply Laplace, it get converted to function containing s. So f of t is converted to f of s. So that's why we took s here. And provided that this integral exists and s here is a parameter, it can be real or complex. So basically we say Laplace of f of t is f bar of s, and in reverse f of t is, if it goes this side, it becomes Laplace inverse of f bar of s. This is basic in this chapter. So now let's discuss necessary conditions for Laplace transform. Maybe this is not asked in your exam, but it is important to you to understand. So firstly, exponential order should be finite. And second one is piecewise continuous functions. That means like this. These are all of piecewise continuous functions. That is not that much important. Let's focus on first point. So a function is said to be of exponential order a if limit t tends to infinity, e power minus at f of t is finite value. So to make you understand, I gave one question here. Prove that f of t is equal to t square is of exponential order 3. So what you should do, should apply the limit. So let's apply limit t tends to infinity, e power, what we should write in place of a, we should write it 3. And what is f of t? T square. So now let's find this. This will become t square by e power 3t. Get infinity by infinity, so let's use L'Hospital and do derivative then. So we'll put limit t tends to infinity 2t by 3 into e power 3t, which is 2 by 9 e power 3t. So if I substitute here infinity, I'll get 2 by infinity, which is finite value. Did here L'Hospital rule applying derivatives. Now we can say that this function is of exponential order 3. See this question. Prove that Laplace transform of this particular function doesn't exist. So what did I say? Necessary condition, exponential order should be finite. So let's see whether the exponential order is finite or infinite. Based on that, we can say whether Laplace transform of this function exists or doesn't exist. So how do we find exponential order? We should apply limit t tends to infinity e power minus at and f into f of t. Here we don't know exponential, we are finding it. Okay, so I took it as a. That is equal to limit t tends to infinity e power t cube minus at e power m into a power n, a power m plus n. We can substitute infinity in place of t and clearly we get e power infinity, which is infinity. So which is not finite. So we cannot find Laplace transform of this function because exponential order is infinite. So this you should remember, this is the necessary condition for a function. So if you have to find Laplace transform, it should have finite exponential order. While practicing only, I'm also making formula sheet side by side. So as of now, we have learned definition. So we have to learn these formulas for sure. Okay, Laplace of 1, which is t power 0. So which is 1 by s. How it came from this formula. So this we use for fractions and this we use for positive numbers. Laplace of 1 is 1 by s. Laplace of t is, in place of n put 1. You'll get 1 by s square. Laplace of Laplace of t square is 2 by s cube, 2 factorial by s cube. Next is exponential functions. If it is a, we'll write minus a, and if it is minus, we'll write plus. This is exponential functions. Next is trigonometric functions. For sine, we write a here, but for cos, we write s. A is nothing but constant. It's like sine 2t, sine 3t, cos 2t, cos 3t. So sine we give importance to a, and in cos we give importance to s. And here both are positive. But coming to hyperbolic functions, we keep negative symbol, and also here same we give importance to constant, here we give importance to s. So for both cosine functions we give importance to s, and in hyperbolic we use minus, in normal trigonometry we use plus. That's it. This formula sheet aside and solve some questions. So to make you thorough, let's practice some questions. Laplace of t cube. Which formula we should use? T power n formula, and here n is positive, so we should use this formula. So we get 3 factorial by s power 4. 6 by s power 4. What is Laplace of t power 1 by 2? Here we should use this formula. Gamma n plus 1 by s power n plus 1. Okay. So gamma 1 by 2 plus 1 by s power 1 by 2 plus 1. So which is gamma 3 by 2 by s power 3 by 2. So this we can write it as 1 by 2 gamma 1 by 2, which is root pi. If you don't know gamma function, just remember this, and when I teach gamma tricks, then you can understand very well. Laplace of e power 2t is 1 by s minus 2, s minus a. Laplace of e power minus 2t is 1 by s plus 2. Okay. Laplace of sin h2t. What is the formula? For hyperbolic function, we should use negative a by s square minus a square. So 2 by s square minus 2 square. And Laplace of cos ht is what? We should use s by s square minus a square. So s by s square minus 1. What is Laplace of t power minus 1 by 2? Here also you should use which formula? Gamma n plus 1 by s power n plus 1. And here n is minus 1 by 2. So 1 minus 1 by 2 is 1 by 2. And here also 1 minus 1 by 2 is 1 by 2. So you will get root pi by root s, which you can write as root pi by s. Let's solve this question. Find Laplace of f of t, where f of t is this piecewise function. So this type of questions we always solve using definition. So by definition, what you know, Laplace of f of t is 0 to infinity e power minus st f of t dt. This definition, my function limits are from 0 to infinity, and if you see here, it is 0 to 1, then my function is 1. If it is from 1 to 2, then my function is 1 plus t. And if it's from 2 to infinity, my function is 0. So I am dividing this into three forms: 0 to 1, 1 to 2, 2 to infinity. Divided into 3 parts. Let's solve this. What is integration of e power minus st? Remember, we are doing with respect to t. So here s is constant. So you will treat it as constant. Okay. Limits are 0 to 1. Next is, here you can use UV rule. So what is UV rule? Integral UV is u integral v minus u dash big integral of u dash integral v. Okay, remember. So now, what is u? This. What is v? This. Why? Annihilate. Last one is exponential term. Okay. So now my u is this 1 plus t. So 1 plus t into integration of this. What is integration of this? It is e power minus st by minus s. Right? Okay. Next, minus big integral. What is u dash? 1 key 0, t key 1. So it will be 1 only. And into integral v. Same integral v is this only. So I'm just writing it like this. E power minus st by minus s dt. Okay, this will be 0. No integration. Next, substitute these values. Which values are these? This is t values. Okay, so you should substitute in t place only. So e power minus s by minus s minus e power 0. Anything to the power 0 is 1. So 1 by minus s. So here 1 plus t into e power minus st by minus s. What is this? Put 1 by minus s outside, so it become plus into 1 by s. Okay. Integration of e power minus st is again e power minus st by minus s. So this will be e power minus s by minus s plus 1 by s plus this whole we should apply limits from 1 to 2. Okay, so first we'll apply 2, so it will become 1 plus 2 into e power minus 2s. Okay, plus this will be 1 by minus s square into e power minus 2s. Okay, next you should apply this. So minus of, you should put 1 plus 1, it will become 2. So 2 into e power minus s by minus s. Okay, again this also minus, put 1 here, it will become minus s, no, it will become plus 1 by s square into, it will become e power minus s. So this is 1 minus e power minus s by s, and here you get 3 into e power minus 2s by s minus 3. Okay, and again here you get minus e power minus 2s by s square. Here you get plus 2 e power minus s by s, and again you get here plus e power minus s by s. So now just all the answer is over. No, if you want you can write more, that's it. Okay, so all s I'll write one side and s square denominators I'll write one side. Okay, minus 3 e power minus 2s plus 2 e power minus s by s. Okay, what is left? This one and this one is left. Okay, plus e power minus s minus e power minus 2s by s square over. This is your final answer. This question we did nothing but by definition, right? Now let's solve another question. So find Laplace transform of this function. So here, do we have anything for powers? We have for t power n, but we don't have for complex functions inside. So simply we will use this formula and divide. What is a plus b whole square? A square plus b square plus 2ab. So this is my function. So here we are going to discuss one. So from now we'll have many properties. So first property is linear property. So now we will also write these properties in our formula. Okay, formula sheet. So let's write here. So this is your linear property. It's very simple. Nothing. If you have inside two functions with plus or minus symbol, simply we'll put constant outside and we'll find the Laplace of these functions. Okay, I'll show you. So here, what is my f of t? This one, right? So what is my Laplace? Nothing. Laplace of t power 4 plus Laplace of 1 plus Laplace of 2t square. This is only a linear property. No need to even study also, right? Okay. So now you know what is formula for t power n factorial by s power n plus 1. Okay. What is Laplace of 1? 1 by s. Laplace of 2t square. The constant simply put outside and write Laplace for t square, which is n factorial means 2 factorial by s cube. Okay, over. So see this question, Laplace of sine 2t into cos t. So we only know formula for sine 80, right? I mean, we don't know formula for product. And in linear property also we discussed what only for plus and minus we can use linear property, but for into we cannot use linear property, right? So we should learn this formulas which I also wrote in our formula sheet. Okay, why we use these formulas? To convert products into minus or plus. Okay, then we can easily do proceed with our formulas. So we are using these formulas now. So now which formula we should use for this? Sine 2t into cos t, which is sine a cos b. So I will write 2 this side 1 by 2. Okay, so 1 by 2 into, I'll write like this, Laplace of 1 by 2 into sine 3t, 2t plus t. Okay, sine 3t plus 2t minus t, sine t. So this is only formula C. Sin a cos b, sin a plus b plus sin a minus b. Okay, now I'll put constant outside. Laplace of, if you want you can write Laplace of sin 3t plus Laplace of, I'm writing directly. Okay, Laplace of sin 3t. What is the formula? 3 by s square plus 3 square plus Laplace of sin t formula 1 by s square plus 1 square. So you understood I wrote directly. This is using linear property. If you want further you can solve. So write s square plus 9. Okay, s square plus 9 into s square plus 1 and with this cross multiplication 4s square plus 12 you will get. Okay, this is your final answer. So to solve this type of questions also we'll use linear property. So we need to create plus symbol. So for that we'll use our formulas. So what is cos 2 theta formula? Sorry, cos square theta formula. So cos square theta formula is 1 plus cos 2 theta by 2. Okay, so in the same way cos h square t formula is also same. Okay, 1 plus cos h 2t by 2. What is sin square t formula? 1 minus cos 2 theta by 2. So this we'll use when we have to convert any powers into these forms. So we have formula for these forms, cos 80 forms. So we'll convert this. Okay, we don't have formula for these squares, so we'll convert. Okay, so in this question here we have t, we wrote 2t. We have 2t, we'll write 4t. Okay, Laplace of 1 plus cos h 4t by 2. Now what it will become? Laplace of 1 by 2 plus cos h 4t by 2. Okay, constant if you want you can put it outside. Laplace of, so you should write like this. Okay, Laplace, this is linear property. You should write in exam by linear property. You should write this step. Okay, next what you will do? Laplace of 1 by 2 is 1 by 2 into Laplace of 1 we can write, which is 1 by s. Okay, so which is 1 by 2 into 1 by s. Okay, next if you see this, I'm putting this 1 by 2 outside, constant, into Laplace of cos h 4t, so which is 1 by 2 into, what is the formula? S by s square minus 4 square, which is 16. So this is my final answer. So in same way, this you know, I think you know this question how to solve. Simply because we have plus and minus, we will use linear property. Laplace of e power 2t, we'll put constant 4 outside. Laplace of t cube minus 2 into Laplace of sine 3t, Laplace of cos 3t, 3 outside. Okay, you know all these formulas. E power 2t is 1 by s minus 2, t cube is 3 factorial by s power 3 plus 1, sine 3t is 3 by s square plus 3 square. Cos 3t is s by s square plus 3 square. So this is your final answer. Now you are good with one property which is called linear property. Now we are going to, so which is like, it's very basic property, so we don't even consider it as a property, okay? So now no need to like or subscribe, but don't get deviated and go watch the next video.